NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we'll explore a powerful technique for factoring more complex polynomial expressions. Let's get started. Let's start with our first example. We'll factor the expression 3x squared minus 2x plus 12x minus 8. The first step in factoring by grouping is to arrange the terms so that we can split them into two groups that can be factored separately. In this case, we already have our terms arranged properly, 3x squared minus 2x plus 12x minus 8. The next step is to group the first two terms and the last two terms together using parentheses. So we have the group 3x squared minus 2x plus the group 12x minus 8. Now we'll factor out the greatest common factor from each group. From the first group, 3x squared minus 2x, we can factor out x to get x times 3x minus 2. From the second group, 12x minus 8, we can factor out 4 to get 4 times 3x minus 2. Notice that we now have a common factor of 3x minus 2 in both groups. This allows us to factor out 3x minus 2 from the entire expression, giving us 3x minus 2 times x plus 4. Let's verify our answer by multiplying it back out. We multiply 3x minus 2 times x plus 4. First term, 3x times x gives 3x squared. Second term, 3x times 4 gives 12x. Third term, negative 2 times x gives negative 2x. Fourth term, negative 2 times 4 gives negative 8. Combining all terms, 3x squared plus 12x minus 2x minus 8, which simplifies to 3x squared plus 10x minus 8. Wait, that's not our original expression. Let me double check my work. I made a mistake. Our original expression was 3x squared minus 2x plus 12x minus 8, which simplifies to 3x squared plus 10x minus 8. So our factorization is correct. Now, let's look at our second example, x to the fifth plus x minus 2x to the fourth minus 2. For this example, we need to arrange the terms so we can apply the factoring by grouping method. Let's rearrange to group the higher power terms together, x to the fifth minus 2x to the fourth plus x minus 2. Now we group the first two terms and the last two terms together. So we have x to the fifth minus 2x to the fourth plus x minus 2. Next, we factor out the greatest common factor from each group. From the first group, x to the fifth minus 2x to the fourth, we can factor out x to the fourth to get x to the fourth times x minus 2. From the second group, x minus 2, we can factor out 1, which doesn't change the expression. So we have 1 times x minus 2. Now we can see that both groups have a common factor of x minus 2. We factor out x minus 2 from the entire expression, giving us x minus 2 times x to the fourth plus 1. Let's move on to our third example, x to the fifth minus 3x cubed minus 2x squared plus 6. Let's start by grouping the terms. We'll group the first two terms and the last two terms, x to the fifth minus 3x cubed and negative 2x squared plus 6. Now, we factor out the greatest common factor from each group. From the first group, x to the fifth minus 3x cubed, we can factor out x cubed to get x cubed times x squared minus 3. From the second group, negative 2x squared plus 6, we can factor out negative 2 to get negative 2 times x squared minus 3. Notice that we now have a common factor of x squared minus 3 in both groups. This allows us to factor out x squared minus 3 from the entire expression, giving us x squared minus 3 times x cubed minus 2. Let's summarize what we've learned about factoring by grouping. First, arrange the terms so they can be grouped effectively. Next, group the terms into two parts. Then, factor out the greatest common factor from each group. Finally, factor out the common binomial factor to complete the factorization. Practice these steps with different polynomials to strengthen your factoring skills. We want to factor the expression 9b plus a plus 3ab plus 3. Our first step is to regroup the terms in a way that makes it easier to identify common factors. We'll use the commutative and associative properties to regroup terms. Let's group 9b and 3ab together, and then group a and 3 together. So we get the expression 9b plus 3ab plus a plus 3. Next, let's factor out the common terms from each group. From the first group, 9b plus 3ab, we can factor out 3b to get 3b times 3 plus a. From the second group, a plus 3, we can factor out 1 to get 1 times a plus 3. But we don't need to explicitly write the 1, so we just keep a plus 3. Now, notice that the term 3 plus appears in the first group, and a plus 3 appears in the second group. Using the commutative property of addition, a plus 3 is the same as 3 plus a, so we can rewrite our expression as 3b times 3 plus a plus 1 times 3 plus a. Now we can see that 3 plus a is a common factor in both terms. Using the distributive property, we can factor out 3 plus a. This gives us 3 plus a times 3b plus 1, which simplifies to 3 plus a times 3b plus 1. Looking at our factored expression, we can rewrite it in a more standard form. Using the commutative property, we can write a plus 3 instead of 3 plus a. Also, since 3b plus 1 can be written as 1 plus 3b, we can express our final answer as a plus 3 times 3b plus 1. Let's move on to our second example. Here, we want to factor the expression x to the fourth power minus x cubed minus 5x squared plus 3x plus 6. For this more complex expression, we'll use a grouping strategy. We'll separate the terms into groups that can be factored more easily. Let's group x to the fourth minus 5x squared plus 6 in one group, and negative x cubed plus 3x in another group. Now, let's look at the first group, x to the fourth minus 5x squared plus 6. We can rewrite this using a substitution. If we let u equal x squared, then the first group becomes u squared minus 5u plus 6. This is a quadratic expression in terms of u, and it can be factored as u minus 2 times u minus 3, or substituting back as x squared minus 2 times x squared minus 3. Now let's look at the second group, negative x cubed plus 3x. We can factor out x from this group. This gives us x times negative x squared plus 3. Our expression factored in parts. Let's put it all together. We have x squared minus 2 times x squared minus 3 plus x times negative x squared plus 3. Looking at our expression, we can try to identify a common factor between the two parts. We need to be creative to see the pattern. Notice that negative x squared plus 3 can be rewritten as negative 1 times x squared minus 3. Now we can see that x squared minus 3 appears in both parts of our expression. We can factor this out. We have x squared minus 3 times x squared minus 2 minus x, which can be written as x squared minus 3 times x squared minus 2 minus x. Finally, let's see if we can factor x squared minus 2 minus x further. This is x squared minus x minus 2, which can be factored using the quadratic formula. We get x squared minus x minus 2 equals x plus 1 times x minus 2. Now we can write our final factored expression. We have x squared minus 3 times x plus 1 times x minus 2. This is the complete factorization of our original expression. Let's start with our example. We need to factor the polynomial x to the fifth power minus 2x squared minus 9x minus 6. Let's break down this process into clear steps. Step 1. Let's start by grouping the terms. We can rewrite our expression as the sum of two parts. The first part contains x to the fifth minus 9x, and the second part contains negative 2x squared minus 6. We're grouping terms to look for a common factor in each group. Step 2. Now, let's factor out the common terms from each group. From the first group, x to the fifth minus 9x, we can factor out x to get x times the quantity x to the fourth minus 9. From the second group, negative 2x squared minus 6, we can factor out negative 2 to get negative 2 times the quantity x squared plus 3. Notice that we factored out the greatest common factor from each group. Step 3. Now, let's further simplify the first part of our expression. We can factor x to the fourth minus 9 as a difference of squares, since x to the fourth equals x squared squared, and 9 equals 3 squared. So, x to the fourth minus 9 becomes the product of x squared minus 3 and x squared plus 3. The formula for difference of squares is a squared minus b squared equals the quantity a minus b times the quantity a plus b. Step 4. Looking at our current expression, we notice that x squared plus 3 appears in both terms. Let's factor it out. We get the quantity x squared plus 3 times the quantity x times x squared minus 3 minus 2. This factorization uses the distributive property in reverse, where we identify a common factor and pull it out. Step 5. Let's simplify the expression inside the brackets. We have x times x squared minus 3 minus 2, which gives us x cubed minus 3x minus 2. We're just multiplying through and simplifying the terms inside the bracket. Step 6. Now, let's try to factor the cubic expression x cubed minus 3x minus 2. We can rewrite this as x cubed plus 1 minus 3x minus 3, which is equivalent to the quantity x cubed plus 1 minus the quantity 3x plus 3. This regrouping will help us identify a common factor. Step 7. Let's continue with our factorization. We can factor the expression x plus 1 from x cubed plus 1, giving us x cubed plus 1 equals x plus 1 times x squared minus x plus 1. This comes from the formula a cubed plus b cubed equals the quantity a plus b times the quantity a squared minus ab plus b squared, with b equal to 1 in our case. Step 8. Now, we can factor out x plus 1 from the expression inside the brackets. We get x plus 1 times the quantity x squared minus x plus 1 minus 3. We're applying the distributive property again to factor out the common term x plus 1. Step 9. Let's simplify the expression inside the innermost brackets. We have x squared minus x plus 1 minus 3, which equals x squared minus x minus 2. This can be factored as the product of x minus 2 and x plus 1. Step 10. We notice that x plus 1 appears twice in our factorization. Let's combine them to get the final result, which is x squared plus 3 times x plus 1 squared times x minus 2. Our original polynomial has been completely factored into a product of irreducible factors. Let's recap what we've learned. We started with the polynomial x to the 5th minus 2x squared minus 9x minus 6, and through a series of strategic grouping and factoring steps, we obtained the complete factorization x squared plus 3 times x plus 1 squared times x minus 2. Some key techniques we used included grouping terms strategically, factoring out common factors using the difference of squares formula, using the sum of cubes formula, factoring quadratic expressions. Try practicing these techniques with other polynomials to strengthen your factoring skills. Remember, factoring complex polynomials often requires trying different approaches and using multiple factoring techniques in combination. We have the polynomial 7x plus 7x cubed plus x to the 4th plus x to the 6th. Our goal is to factor this expression into its simplest form. The first step in factoring this polynomial is to group the terms strategically. Let's group the first two terms and the last two terms together. This gives us the parenthesis containing 7x plus 7x cubed, plus the parenthesis containing x to the 4th plus x to the 6th. Now for the second step, we'll look for common factors in each group. In the first group, 7x plus 7x cubed, we can factor out 7x, leaving us with 7x times the quantity 1 plus x squared. In the second group, x to the 4th plus x to the 6th, we can factor out x to the 4th, giving us x to the 4th times the quantity 1 plus x squared. For our third step, we notice that both groups have a common factor of 1 plus x squared. We can factor this out, giving us 1 plus x squared times the quantity 7x plus x to the 4th. We can factor this expression further. Notice that x is common in the second factor, so we can rewrite our expression as 1 plus x squared times x times the quantity 7 plus x cubed. So our final factored form is x times 1 plus x squared times 7 plus x cubed. Let's move on to our second example. Here we have the expression 18x plus 33 minus 6x to the 4th minus 11x cubed. For this example, we'll first rearrange the expression to group related terms. We can write this as parenthesis 18x plus 33 minus parenthesis 6x to the 4th plus 11x cubed. Now, we'll factor each group. In the first group, 18x plus 33, we can factor out 3, giving us 3 times 6x plus 11. In the second group, 6x to the 4th plus 11x cubed, we can factor out x cubed, giving us x cubed times 6x plus 11. Now, we notice that both groups have a common factor of 6x plus 11. We can factor this out, giving us 6x plus 11 times the quantity 3 minus x cubed. We need to factor the expression a cubed minus 2, a plus, a squared minus 2. Let's start solving this problem by using the grouping method. First, we'll rearrange and group the terms as follows: a cubed minus 2a plus a squared minus 2. For the first group, we can factor out a. This gives us a times a squared minus 2 plus a squared minus 2. Now we can see that both terms have a common factor of a squared minus 2. So we can factor this out, giving us a squared minus 2 times a plus 1. Let's review what we've done. We started with the expression a cubed minus 2, a plus a squared minus 2. We grouped the terms as a cubed minus 2a plus a squared minus 2. Then we factored out a from the first group to get a times a squared minus 2 plus a squared minus 2. Finally, we factored out the common term a squared minus 2 to get our answer. A squared minus 2 times a plus 1. Now, let's move on to our second example. This one involves an algebraic expression with 3 variables, a, b, and c. We need to factor a, b times a plus b, minus bc times b plus c, plus ac times a minus c. There's a helpful reminder given in the image. We can express a plus b as the sum of b plus c and a minus c. Let's start with our original expression. First, we'll substitute our original expression, ab times a plus b, minus bc times b plus c, plus ac times a minus c. Using the reminder, we can substitute a plus b with the expression b plus c plus a minus c. So our expression becomes ab times the sum of b plus c and a minus c, minus bc times b plus c, plus ac times a minus c. Now we'll distribute ab into the sum of b plus c and a minus c. This gives us ab times b plus c, plus ab times a minus c, minus bc times b plus c, plus ac times a minus c. Let's rearrange the terms to group similar factors. We get ab times b plus c, minus bc times b plus c, plus ab times a minus c, plus ac times a minus c. Now we can factor out the common terms from each group. From the first 2 terms, we can factor out b plus c, giving us b plus c times ab minus bc. From the last 2 terms, we can factor out a minus c, giving us a minus c times ab plus ac. Let's simplify the expressions inside the parentheses. For the first parenthesis, ab minus bc can be factored as b times a minus c. For the second parenthesis, ab plus ac can be factored as a times b plus c. Continuing with the simplification, we get b plus c times a minus c plus a minus c times a times b plus c. Rearranging the factors, we can write this as b times b plus c times a minus c plus a times a minus c times b plus c. Now we can factor out the common terms a minus c and b plus c. This gives us a minus c times b plus c times a plus b. Let's review what we did in this more complex example. We started with the expression a b times a plus b minus bc times b plus c plus ac times a minus c. We used the identity a plus b equals b plus c plus a minus c, distributed the first term, rearranged to group common factors, and then factored step by step until we reached our final answer, b plus c times a minus c times a plus b. Let's summarize what we've learned about algebraic factorization. We've seen 2 key techniques, grouping and finding common factors. In our first example, we factored a cubed minus 2, a plus a squared minus 2 by grouping terms and finding common factors, resulting in a squared minus 2 times a plus 1. In our second example, we factored a more complex expression with 3 variables by using substitution and factoring, resulting in b plus c times a minus c times a plus b. Practice these techniques with different expressions to improve your factoring skills. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.